This is going to be an example of dividing rational expressions. When dividing fractions, we rewrite them as multiplication. So if I examine this problem, I want to rewrite this as a multiplication problem. We keep the first fraction the same, change division to multiplication, and do the reciprocal of the second fraction. Now that we've rewritten it as multiplication, we need to factor all the numerators and denominators. And this is actually the most lengthy part of the process because we have a couple difference of two perfect cubes right here and the sum of two perfect cubes right here. Now, if you recall, we do have a formula for factoring perfect cubes. A cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. And then a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. So for the 64x cubed minus 1, we're going to use the second one of those. We're going to use this formula right here. So if I have 64x to the third minus 1, I want to rewrite that in the form of something to the third minus something to the third. So that's going to give us 4x to the third minus 1 to the third. That means my a value is going to be 4x and my b value in this equation is going to be 1. Well, I need to also know what a squared and b squared are. So if a is 4x, then a squared is 16x squared, if b is 1, b squared is 1, and a times b is 4x. So if I fill that in, I'll get 4x minus 1 times 16x squared plus 4x plus 1. Now the next one, the 6x cubed plus 162, we may not recognize that right off as the sum of two perfect cubes because 6 is obviously not a perfect cube. But there is a common factor, or a greatest common factor of 6 in this problem. And if we factor out the 6, we will end up with 6 times x cubed plus 27. And x cubed plus 27 is the sum of two perfect cubes. We can rewrite this as x to the third plus 3 to the third. This will give us, when factored, x plus 3 times the quantity x squared minus 3x plus 9. So if I plug all of these in and factor the other denominators, I will end up with all of this beautifulness down here. Notice that the denominator of the first fraction, there was a greatest common factor of 2 that I could factor out. And in the second one, there was a 3 I could factor out. The quadratic that's left in those does not factor any further, but it's okay because our next step is going to be to reduce. And hopefully you'll notice that we have this x cubed minus 3x plus 9 in this denominator, but we have it up here in this numerator. And when we have the same thing in the numerator and the denominator, they equal 1 and reduce. Same thing with the 16x squared plus 4x plus 1, and then notice it's down here in this denominator. So our next step is going to be to reduce. I'm going to write what we have left over, and then hopefully you'll notice that the 2 times 3 in the denominator is 6, and we'll reduce with the factor of 6 in the numerator. This will give us a final answer of 4x minus 1 times x plus 3. Thanks for tuning in.